Guys, what's going on here? It's the Science Savages, and we're here to talk to you about cells, hypertonic and hypotonic solutions, and the cell membrane. So the cell theory is composed of three parts. It's all living organisms are composed of cells. All cells come from other cells, and the cell is the basic unit of life. So in the I'm going to be talking about the history of the cell. So the history of the cell is Anton von Leeuwenhoek was the first to see them. Um, he called them tiny animals because that's what he thought they looked like. And then Robert Hooke came up with the term cell after thinking that they looked like little brooms. And then Matthias Schleiden was the one to find out that all plants were made of cells. And then Theodor Schwann said that all animals were made of cells. And you can remember that all animals are made of cells because Schwann kind of sounds like swan, which happens to be an animal. Yeah. Okay, I guess that's that. Okay, and then Rudolf Virchow said that all cells come from pre-existing cells, so they don't just kind of spontaneously generate, which would be kind of cool, but they don't. So, now to Steven.
Alright, take 95. I'm going to be going over cell membrane, hypotonic, hypertonic, and isotonic. Alright, so what hypo, and isotonic mean? Okay, hypertonic means that there is a higher concentration of water molecules inside the cell. What I use to remember that would be all the hyper children penned up inside their crib and they're trying to get out. Well, they're all inside the crib, but with water molecules, that crib would be the cell. So there's a higher concentration inside than outside. Now, hypotonic, that means there's a higher concentration of water molecules outside the cell, all right? What I like to do is I like to use that O for outside. That helps me remember a lot. Now, isotonic, it's completely different from the rest. Means that there's an equal concentration of water molecules in and outside. Pretty easy. Now, cell membrane. The cell membrane, its main function is to protect the cell from its environment, but it also has a semi-permeable membrane, which means it can select nutrients to go inside the cell and waste to go outside, which is a pretty good deal if you ask me. I think of it like a house, you know, especially with that protecting the cell from its environment. We Floridians were the cell, and we need that house, cell membrane, to protect us from that brutal winter down here. It gets pretty crazy. We're talking like 50s. Man, that's pretty cold. All right, well, it protects from the cell, and then the doors in the house, that could be the semi-permeable membrane that allows you to go and then come back too. So it allows waste to get out of the cell and nutrients to get inside the cell. So basically just anything that's good for the cell. But then in plant cells, it's a cell wall. Now do not get them confused. The cell wall is in plant cells only. It's not in animal cells. Animal cells have the membrane. Now, the cell wall, it's not selectively permeable, so that's how you can tell the two apart. But they do both protect the cell from its environment, all right? Now, the cell membrane also consists of a phospholipid bilayer with hydrophilic heads and hydrophobic tails, which creates, like, the heads right here, and then you got, like, the tails, all right? So you get kind of like... I don't know how to describe it. It looks like a bunch of noodles coming down from the ceiling. It's kind of weird. But yeah, so that's what allows the actual nutrients and waste to get in and out of the cell and gives it that selective permeability. All right, guys. That's it for cell membrane. Got a little cell wall in there. Hope you guys enjoyed it. Hypo, and isotonic. Don't forget them children, you know. All right. See you later.
Thank you guys so much for watching. Don't forget to smash, decimate, and destroy that like button, and subscribe for more daily science videos or whenever we get back on the channel. Thank you. Goodbye.